Welcome everyone. Now we are going to discuss about encoder and decoders. We discuss about encoder first. So what is encoder? Encoder is a combinational circuit. It will be having multiple inputs and multiple outputs. In general, the encoder will be having 2 power n input lines and will produce n number of outputs. Okay. So generally we can say the encoder will generate the binary code corresponding to the input. Okay, this is the schematic diagram of encoder. Look at here, it will be having 2 power n number of input lines. Output will be having n number of output lines. Okay, so this is called encoder. So we are having 4 types of encoders here. They are 4 to 2 encoder, octal to binary encoder, decimal to BCD encoder, priority encoder. So we will discuss about octal to binary encoder here. We will discuss elaborately. So octal in the sense we can say 8. So hence it's called as 8 to 3 encoder also. So 3 is n and 2 power 3 will be 8. So it is 8 to 3 encoder. So this is the schematic of 8 to 3 encoder. It will be having 8 inputs which was named Y0, Y1, Y2, Y3, Y4, Y5, Y6 and Y7. Okay. So at the instant, any one of this 8 inputs will be activated. So the output will be having the binary equivalent of that particular input. So this is the concept of 8 to 3 encoder. Okay. So this is the truth table. We are seeing the truth table of 8 to 3 encoder. So here the inputs are 8 number of inputs. Y0, Y1, Y2, Y3, Y4, Y5, Y6, Y7 and the output is A0, A1, A2. So for example, so Y0 input alone, it is 1. So other inputs are set as 0. So Y0. So the input is Y0. So the output will be producing the binary equivalent of 0. So the binary equivalent of 0 is 0, 0, 0. Okay. Then the Y1 input alone has been set as 1. The other inputs are 0. So the binary equivalent of 1 is 0, 0, 1, which is at output 0, 0, 1. Likewise, Y2 input is set as high. The other input is 0. The binary equivalent of 2 is 0, 1, 0 that was present in the output. Likewise, for all 8 inputs, the corresponding binary codes are given at output. Okay. So we can see the circuit representation. To construct the circuit, we have to go for K-map for every output alone. So from here we can say, so first we design the circuit for A2. So for A2, the output is high, that is 1 for 4 combinations. They are Y4, Y1, let's see. So for A2, there are only 4 combinations. They are Y4, Y1, Y5, sorry, Y6 and Y7. Okay. So the A2 is equal to Y4 plus Y5 plus Y6 plus Y7. Likewise, A1. A1, it is also having high for 4 inputs. They are, one is Y2, another one is Y3, Another one is y6, another one is y7. So a1 is equal to y2 plus y3 plus y6 plus y7. For a0, a0 is 1 for alternating input. So for a0 is equal to y1, y1, and then y4, sorry, y3, another one is y5, another one is y7. So with this logical equation, we will design the circuit with basic gate. This is the logic expression of the decoder, A23 decoder, which was derived from the truth table. Okay, this is the circuit design with the help of that equation. Okay, let's see if the Wi-Fi input alone set 1 and other inputs are sets as 0. What will be the output of the decoder circuits? Let's check now. Okay, so for Wi-Fi alone 1, other inputs y0, y1, y2, y3, y4 and y6 and y7. So all the 7 inputs are 0. So Wi-Fi alone 1. Then the 3 OR gates are there. So the first OR gate will get Wi-Fi. So here the input of OR gate is 1 and the third OR gate will be getting that Wi-Fi. So here the input is also 1. So all the remaining inputs are 0 for these OR gates. So if any one of the input is 1 means the OR gate will give the output as 1. So the output of this OR gate will be 1 and output of the third OR gate will be also 1. So this OR gate will never getting the input as 1. So all the input of this OR gate is 0. So the output of this OR gate is 0. So look at that, the output is 1, 0, 1. So which is equivalent to 5. So the Wi-Fi input is 1. Okay. So now we have successfully designed the 823 decoder. Okay. Next we discuss about decoder. So decoder is also a combinational circuit. It is also having the multiple input and multiple output. The decoders are generally used to convert the coded inputs into coded outputs, where both input and output codes are totally different. Actually, the decoder is nothing but doing exactly the reverse process of what is encoder is doing. Okay, so this is the schematic representation of decoder. Look at here, it is having n inputs and 2 power n outputs. It is exactly reverse of the encoder. Okay, so if the decoder will have n input means the output will be having 2 power n bits. The output values will be varying from 0 to 2 power n minus 1. Okay, so for example, 2 to 4 decoder in the sense the input will be having 2 bits. The output will be 2 power n minus 1. 2 power n is, sorry, 2 power 2 is 4. 4 minus 1, 3. So the output will be 0, 1, 2, 3. Generally, it is called as binary decoder. So this is the truth table of binary decoder. So we'll be having 2 inputs A comma B. So 2 inputs will be having 4 number of combinations. The output will be having Q0, Q1, Q2, Q3. So for binary 0, 0, it will activate the output Q0. It will 0, 1. It for binary 1, which will activate the output Q1. If it is 1, 0, it is equivalent of binary 2. It will activate the output Q2. If it is 1, 1, it is equivalent of 3, which will activate the output Q3. Okay. So with this, we can go for designing this circuit with the help of K-map. We will be deriving the circuit. Okay, so let us see if the outputs are, for example, 0, 1. If the input is 0, 1, let's see how it will happen. So here it will be 1 and here it will be 0 because of this NOT gate. It will get inverted. Okay, so the first AND gate will get 1 and 0. So for as it is this AND gate, the output is 0. D0 output is 0. The next AND gate will be getting 1 and 1. So both the inputs are 1. So the output of this AND gate will be 1. Next, this AND gate, third AND gate will be getting 0 and 1. So any one input is 0, then the output of this AND gate will be 0. The next, fourth, this AND gate will be having 0 and 1. So the output of this AND gate is also 0. So we just verified the truth table. For 0, 1, the output of D1 is 1. So hence the truth table is verified. We have designed the 224 decoder. Okay. So where the decoders are applicable: memory addressing, control units, display drivers, address decoding, the digital communications, and error correction. So these are the application areas of decoders. Okay. So thanks for patient listening. Thank you.